right now we're going to focus on bearings. Okay, so the first thing that I need to talk with you all about bearings is that you will list either the north to the south first. That is typically the one that's always given first. Okay? Only north and south is the one you're going to focus on. So here's what I'm looking at on this one right here. The angle is coming up from our origin, but we're going to come from the north, and you're going to see what is the angle to get from the north to there. So if we know that this is 90 degrees, what is 90 minus the 56? 34 degrees. So the little 34 degrees goes in here. So here's how we're going to list it. We started from the north, and we measured 34. Do you guys notice the little degree marking in there for you? Yes? And you went towards the east. And it will always be listed in this order. So you'll go north, how much to the east, or north, how much to the west. Okay? You will never say west, how much north. It's just not how it's listed in everyday life when people use this. Okay? So always north and south. Yes? Okay. So take a look at number 2 though. I would not use north because he's in the lower quadrants. I would use the south. Okay, and I notice it was already listed for us as 85 degrees. Do you need to find that then? No, so we list south first, 85 degrees, and then which direction did we go towards? West, I like it. There you go. Okay, go to the very last problem. What number is it?
I don't know, the whole one right there.
13. Yes, but when people are using a navigational compass, they're always using a northeast, southwest. So they always start from facing north or facing south. So it's just how the navigational terms have come about these days. Okay. Now there is another term, I have to think of what they call it. There is a term in navigation that basically says face east and turn like our unit circle. So let me think about what that term is called. So there is something that tells you starting from the initial side of something.
Easter.
Maybe. It's something different though. I'll think on it. Okay, what number is the last one?
13.
13. Backside.
Oh, ow.
Okay, you leave your house. So look, this is a fabulous drawing. This is you. Huh. I'm a great artist, aren't I? That's you. That dot. And it says, you run 7 miles due west. Which way should I go? To the left. And you're going to put 7 underneath it. So now you're here. Okay, and then it's followed by 5.5 north. Which way should I draw? Up. Like this. And I'm going to label it 5.5. Okay. At that time, what is your bearing from your house? So we are talking back to the house. I'm going to label that this is the house. If you notice, we just drew a right triangle. Okay. And we have knowledge about how to find this angle right here by doing SOHCAHTOA. Okay. And I have opposite and I have adjacent. So which one should I use? Tangent. And if we're finding an angle, we're going to use tangent inverse. And it's going to be opposite over adjacent. Okay, now look at all your answers. Are your answers in degrees or radians? Degrees. So what mode should you be in? Degrees as well. Okay, so go ahead and type it in. I'm looking at all these degrees. None of them have decimals, so give me the closest. Nearest 38 degrees? Okay. Okay, now, here is where we need to get a little bit crafty. It says, what is your bearing from your house? So first of all, I notice that we're going up, so I'm going to draw north. And then it turns this way. It turns west to get there. So what is 90 minus the 38? 52. Okay, so our answer is going to be that we face north, turn 52 degrees towards the west. Is that one of our answers?
Yes.
Yes, which one? A, B, or C, D? C. Okay. So one of the most confusing things in the past that students tell me is that I'll give, say, a 38 degree like this, and they actually have to find some complementary angle to go with it. Okay, so just keep in mind, if it says from this place, you're looking up or down first, okay, and then east and west next.
Okay, so for the bearings, is that when you use the minutes and seconds?
You can totally use a bearing. It just, what minutes and seconds did for us that we learned about is it got more and more precise. So instead of just saying turning 1 degree, it was 1.5 degrees by the minutes and the seconds. So especially for people who are going very long distances, like let's say astronauts, right? If you say 1 or 2 degrees, it makes a very large difference in the long run if you're going thousands of miles. Okay, so it helped get more precise. What was that movie that came out where they left the astronaut on Martian?
Now he was dead.
Didn't they have to do a very precise angle and shoot out and grab him at the very end? Okay, that would be a great application. Don't just 1 or 2 degree in it.
Okay, you stay there while we just.
So frustrating. Okay, here we go. Next. Flip. Number 6. 3, 2, 1. Okay, first thing I want to pick up is, without reading number 6, I want to pick up this term, angle of elevation. And there looks like there's a little room in the box. Let's go to the very top. Okay, let's write about angle of elevation. Yeah, we are, but I'm using the space in number 1. Angle of elevation means that you, that's God again, I'm such a good artist. You look straight out, and then you elevate your glance up. And that's really where you are looking, is the solid line. Okay, in the future, you may have an angle of depression. Yep. Okay, here we go. Angle of depression. So here's you again. You look straight out. And down, down, down you go for being depressed. Okay. This is not the term I was thinking about that I was saying. There is a navigational term to tell you to face east and use the unit circle as your bearings. And not the term I was thinking about. So if you see those terms, you need to know whether to draw looking up or looking down, because it makes a difference with your angle. It's with the complementary issue. Okay, let's go back to number 6. Okay. Tallest TV tower transmits from North Dakota. Fun fact of the day. It can't be about number 6 yet. I don't know. Okay, let's move on. We'll look it up when we're done here. Here we go. From a point on level ground, 1 mile from the tower. Oh, so it's not the tower, is it? You are standing 1 mile from the tower. The angle of elevation is 29.5 degrees to the top. So here's my picture. Here's you. Should I use 5280 feet or 1 mile because the ending says approximate to the nearest foot? 5280. Okay, here's my tower, nice and tall. I don't really know how tall it is. Okay, and angle of elevation is looking up, so this is your 29.5 degrees right here. Approximate the height of the tower to the nearest foot. Okay, so this is something that the original cartographers of Colorado would go out and do, is that they would stand a distance from a mountain and they would do an angle of elevation and figure out how tall it was. That's how they did all the original topography, and it was almost down to the exact decimal when they went back and did it with technology as soon as it came available. I mean, it was a very good science. Okay, so here we go. SOHCAHTOA. Opposite. Adjacent. Tangent. Good. Okay, here we go. Tangent of 29.5. This is a degree. Are we in degree mode still? Equals x over 5280. I need one move to solve for x. What am I going to multiply both sides by? Okay, type that straight in. Look at the directions they want to the nearest foot. So no decimals. Pick up your calculator, please. Nearest foot. Are you getting somewhere around 2,900? Oh, actually closer to 3,000? Lovely. That's what I got too. Degrees. No, absolutely. Great question, but guys, look. Right here. Degree. Because it's 29.5 degrees. All right, at this time, I'm going to pause. You guys are going to set up number 7 on your own, and we're going to check in there. All right, focusing on number 3. Okay, so this is a completely different application that I just wanted to give you an example of. You will have one of these in your assignment tonight to practice yourself, but it's not something I think I'm going to throw on your test. I haven't decided yet. But I want you to know of it. Okay, so let's talk about the concept of number 3. What is something that moves in a harmonic action? Buoys. Oh, that was on our last test, wasn't it? Goes up and down. What's something else?
Sound
Waves.
waves.
Yo-yos. Good. They start to lose steam after a while, so it's a little bit modified. What else bounces like that?
A hard bounce. Windmill.
Yeah, a windmill actually is kind of like how the location it is from the ground. You can trace that. That would be really good. Yes. The things that tick back and forth, even a great pendulums. Very good. Okay, now, first thing I would like us to write down, anything that moves in a simple harmonic action can be written as a trigonometric function, specifically cosine or sine. So you can get this problem as a cosine or a sine, and it really does not matter which one. This is a Greek W, so that's why it's kind of shaped the way I shaped it. I don't know. Okay. We do know that the A is our amplitude. Some of you asked this question on your last test. This is our total maximum displacement from top to bottom is our amplitude. Okay. So, and then also we have the period here, which is impacted by the number in front of the T cell. Okay, so the first thing I would like to do is it talks about the maximum displacement. This is our amplitude. And we know, go ahead, write that word in there so you can have it later. Your amplitude is always listed as a what? Positive. So remind yourself and put absolute value bars around it. Okay, so let's take a look at the question that I have. This object, the amplitude is a positive 6. Okay, so for part A, the maximum displacement is 6 inches. Okay, the next one I want to do is the time required for one cycle. That's C. Okay, this is asking for period. And we know how to find period. It's going to be 2 pi divided by the number in front of the t. So 2 pi divided by the pi over 4. Keep, change, flip. Isn't that what you guys say? Okay. So, that's a nice number. What is that? 8. So it takes 8 seconds. So if you were to make the graph of this, you would go 4 tick marks and mark 8 seconds to complete the cycle. Yes? Okay. Now, what is new in this thing is that it's talking about the frequency. So the frequency on here is a pretty simple concept, but what we're going to do is we're going to take the period and we're going to reciprocate it. So the frequency's relationship to the period is that we reciprocate it. So let's go ahead and write that formula down. And that's why I did them in that order. I did 1, 2, and then this is number 3 that I did. Okay, so frequency is going to be 1 over the period. Okay, so we have 1 over 8. So let's really think about what that is saying now. It takes 8 full seconds to get a full cycle. What this is relating, the frequency is relating back to every second. So that's why we reciprocate it. Only, so I'm doing this because that's the cosine shape, yes? Okay. So only like 1/8 of it, that's how much you will see in the first second. So if you want to write a little note to yourself, frequency is based on how many cycles per second. That's what frequency is determined. How many or what portion of the cycles per second. Yes? Right, so that one's completely a new concept. You have all those formulas written down. So kind of some new terms and terminologies. Are we doing good? Awesome. All right, let's go to number 4. Okay, number 4. Oh my goodness. Noah, head up. Thank you. All right. Number 4, our goal is to find the total length of x. But can you guys see the right triangle in the top? Okay, so maybe I'll call that A. You're going to find A first. Do you see the triangle in the bottom?
Yeah.
Okay, then you'll find B. Looks like we'll use tangent for both of them. And then you will find x by taking your values of A and B and adding them together. Equals C, but they labeled x, yes? Okay. I'm going to skim over this one because I feel like it's something that we've talked about. Go ahead, write in the answer is about 632.
Wait. Where'd you get that number?
Oh, I already did it before.
Oh, wait, so we're doing it
No. We want to skim over it.
now? We're not learning that.
No, it's because we've done it a lot in the past, and I want to do something new
Too
with you.
smart.
Okay. All right, let's take a look at number 5. Do you see the little triangle in here? And then do you see the large triangle? Okay, so with the little triangle, you have enough information there to find this side, this leg. I'm going to call it an A. And then in the big triangle, you have enough information to find the big leg, which I'll call B. And then once you have that information, how can you find x? Subtract. B minus the A will get us to what they call x. Okay. And just for the record, it should be somewhere around 87 on this one. Good. All right. Let's start to hit some of this new stuff. Flip over your paper. thing, this picture was given to you. I am not always going to give this picture to you. So as we read through the problem, I want you to kind of visualize and think to yourself, can I create this picture just by reading it once? Okay? So, think about it. A helicopter hovers 950 feet above a small island. Would you be able to draw the island at the bottom and say 950 up and draw a helicopter up here? Wouldn't you love to see what my helicopter looks like?
Yes.
Next, this is an important part. The angle of depression. The helicopter looks straight out and then follows his line of sight, which is why this is labeled as 40. So if this is 40, what is the inner angle actually right here?
50 degrees.
50 degrees, and that's what we need to label. Okay, now that we actually have an angle in here, or could we actually do the alternate interiors and label this one as 40 if we wanted to? Now that we have those, can we do SOHCAHTOA? Okay, let's go ahead and start to set it up. Let's see here. It doesn't matter which one we use. I'm going to use the 50 degrees. So I have opposite and adjacent. So who am I going to use? Tangent. Okay, you're going to multiply by 950, and it says round your answer to the nearest whole number. Okay, just looking at it, I know in my calculator, 40 degrees is smaller than 50 degrees, so this answer better be over 950. Okay, what's that, Micah?
Oh, 1,100.
So 132? Yep, I totally agree. He is pretty level. And so you are saying, you are directing and making sure everybody's looking the same way. So you see angle of depression, you see an island. So again, you like envision like you're looking straight out towards the door or something like that. You look straight out and you say, okay, the island's down there. So I am looking this 40 degrees down to the island where he's looking. So I'm looking straight out and then looking down, I see this island.
But he's on top of the island, so
He's not on top of it. The island's over there.
the helicopter.
And in fact, he is 1,132 feet from the
Oh,
island.
the guy's on the helicopter.
Yes. The island's is way out there. Way out there. Okay. This one, number 9. Shh. This one is actually really applicable right now because a lot of buildings are renovating, including our own. Okay? And in between now and when buildings were built, regulations change. Okay, so ramps typically, if you need wheelchair accessible, those always weren't there. So, for instance, my brother is in the construction management, and he typically does streets with the ramps. He has to make sure that the ramps are at a certain angle. And if they're not at a certain angle, he gets stopped for it, or he has to rip it out and he has to put a new thing and figure it out. So let's take a look at this. We are trying to find, this is like we are inspectors going in. We are trying to find the angle of elevation. We don't know, I don't know what the regulation is for the angle of elevation, but I know that most roads around here, newer roads, is a 6% grade, 0.06. Okay, as a radian. That's, if you look at I-70 coming up from the tunnel, down from the tunnel, it's a 6% grade. That's what they have to make the roads coming down. Now, if you go to the old mining logging roads, right, they're straight up, no regulations. But if they had to redo that road, it would have to get graded. No, they did not care about safety. Okay. All right, here we go. A ramp is to be built beside the library. Find the angle of, Find the angle of elevation. So looking towards the library straight up. of the 21-foot ramp when its final height is 4 feet? Opposite, hypotenuse. Sine. So, okay, so, and since we're finding an angle, we have to use its inverse. Sine inverse of 4 over 21. Are you in degree mode? Okay, go ahead, type it in. And I want the nearest tenth as your answer. $11.0? Okay, that is something you can tell me. If it wants tenth and it doesn't have a tenth, you say 11.0. Is the degree symbol already in there, or do we need to write it? Yes, it is. Isn't that nice? Now, I do have to say, frankly, 11 degrees for a ramp, it's pretty tall. Probably between 6 and 8 is regulation currently. Don't quote me on that, though. Okay. All right. Yeah, actually, you could.
Does he actually do that?
He'd be like, here's the facts, blah, blah, blah.
Does he actually do that?
Yes.
He's gonna spit some knowledge on him. Where does he live?
Here.
It's called.
Yep.
It's called.
He lives in my spare bedroom. I see him a lot. Okay. All right. Number 11. We're skipped, yep. Number 11. This one uses bearings. We have to get straight how we're drawing this one. Let's read the whole problem before we draw it. A boat leaves the entrance to a harbor. Hey. Pause. Boat leaves the entrance to a harbor and travels 100 miles at a bearing of north. So which way is he looking? Up. And 58 east. This way. Okay, so he's looking that way. How many miles north and how many miles east has he traveled? So we're going to draw this. Here we go. Here's the harbor. Boop. He looks north and directs his attention to the east or west? East, so this way. And draw a solid line for me. Okay, that's going to be the 58 degrees. Connect it and make a triangle for me. So how many miles north? This is going to be our A. That's what we're going to find first. Someone answer, please. Student speaking. And then how many miles east? B. Okay, and we have enough information here to get us started. Yeah? All right, so here we go. 58. Let's do A first. That's adjacent. And 100 is our hypotenuse. So what are we going to use? Cosine. Okay, go ahead and type it in. Directions say nearest tenth of a mile. It's got to be less than 100. Hypotenuse is always the largest. 53.0. Good. Okay, if we were to set up B, if we were to set up B, are we going to use tangent or sine? Sine. Good. Okay, and when we do that, it should come out to be about 84.8. All right, last one that we're going to do, number 12. So, especially in Colorado, how many of you have been up to a fire station? Like, not just like a fire station out here, like in the mountain fire tower. That's better. Okay, so I know that there are some old ones here, but there's a big one that you can go hiking out just outside of Colorado Springs. and they would monitor towards our
Then
direction.
you get some in
They
and
would
out.
have someone here monitoring that direction. Okay? So there'd be multiple towers. So what would happen is someone would be on shift. Okay? And you have these two people. One is over here. These are miles apart. Okay? And all they do is they look for fires. And they have to be able to say, go there, and get there fast. Right? Okay. So what this is saying is that the forest fire, ranger fire, he sees one that's directly south. Okay, so directly underneath him. So you're going to draw a dot, and you're going to go directly underneath him. Draw it down. He doesn't know how far it is from him, so he calls up, probably telegraph at that time, the other guy and says, hey, there's a fire. I need you to look right now. This guy is 7 miles east, so he's out here. He is straight east. They make these towers straight from each other. So draw a line going straight east. Label it 7.
He's looking down, right? You draw a line down.
Okay, so let me start doing what I'm motioning out here. Okay, so here's the first ranger, and he sights a fire directly south.
What's that ranger's name?
Bob. Okay, second ranger. Ranger Rick
Ranger
is 7 miles. Hey, you're losing sight. You're losing sight. Literally. Okay. Rick is out here 7 miles to the east, and he also sights the fire. The bearing from the second ranger is he looks south. So draw a dash for he looks south, and then draws his attention to the west, 35 degrees. So it's a 35. Is that the one that we want in our triangle? No? Okay. So 55 is in our triangle, or you could use the 35 down here. Okay, so now that we have that information, can we figure out how far directly that he needs to start running towards that fire? Yes. Okay, so I see tangent of the 55 is x over the 7, and we're going to multiply out the 7. Directions want the nearest tenth. 10. 10.0, good. I like that you guys are doing that with the directions. Okay, now, logistically, you are not going to send a man running 10 miles with all gear on. And when my husband puts on his fire gear,
The firefighter?
it's like 60 pounds on his pack, and the lieutenants put an extra rock on his pack to get the extra weight in there. Okay, it's really heavy. So let's talk about other ways that they would be doing this. You have lots and lots of crossroads, yes, in the mountains. So they would say, they would look at a map, mark 10 miles out, they find the nearest crossroad to send people in with their trucks and gear, and then start running towards the fire. Okay, so lots of logistics in there as well. All right, pause 1 second, I'm going to close this out, close out the video. You guys are going to do a similar worksheet tonight.